Mega Mechatronics.
Alright, welcome back to the Mega Mechatronics Bootcamp series for mechanical engineering. We're covering topics in materials, and we are going to be talking about corrosion in this video. Corrosion is the chemical process that gradually breaks down the materials, where electrons are exchanged and new molecules are formed. And there are a lot of different classifications of corrosion, including things like erosion and wear. We're going to focus on these chemical processes. I feel those are the most important that we need to start with. So here's an old 1911 from World War II. It was probably buried under the ground. And here's some aluminum that has oxidized and rusted, you could say. And here's some copper currency with that telltale green copper ions sitting on the top there. So the corrosion process that we're going to be looking at is similar to batteries, and that's actually what batteries are exploiting. So we have an anode metal and a cathode metal, and those are separated by an electrolyte. And there is an electrode potential between those two different metals. And when we close that circuit, we start equalizing the electrons because the anode has too many negative electrons and the cathode has doesn't have enough of those, or it has too many positive electrons. So we close the circuit, it starts equalizing those and pulling those electrons from the anode, and we harness that potential. So the potential energy is the voltage, and then the volume of the electrons flowing would be the amperage. So an example of an oxidation process with iron is where the oxygen in the atmosphere, the air, will react with the water, so like humidity and things like that. So there's water in the air as well. Those two things react with the iron and produce iron oxide. So you can see how that degrades that base metal and turns it into that brown rust that we are used to seeing. And that also happens with other materials such as copper. But copper does quite a nice, it creates this green patina, and that's actually a protective layer, and that's why the Statue of Liberty is still standing. So now we're going to look at the nobility of metals in galvanic corrosion, which is a subset of corrosion. This is where metals have different electropotentials. So this chart here is showing the difference in electropotential. So at the top you see those numbers, negative 1.6 to 0.2, and magnesium, zinc at the very top. And we have some mild steel here, cast iron, copper, stainless steel moving down, and gold is near the bottom there. So the difference between the electropotentials, we call that dissimilarity of the metals. And something to point out here, which is very relevant, is that copper and the lead tin solder. And that's why we use that type of solder with tin in it with the copper, because they're so similar. We're not going to get that galvanic corrosion because their electropotentials are nearly the same. So they're not going to eat each other up. On the other hand, we have aluminum alloys really high up there. And if you combine the aluminum with, let's say, a stainless steel near the bottom, you're going to have trouble where that aluminum is going to start degrading. So, and same with copper. When you connect aluminum to copper, you need to seal it off, use some zinc paste. So you see that zinc is less noble, and the zinc will actually sacrifice itself. So to sort of illustrate the process in a fun, twisted way, we'll go back to the medieval times. So let's say this guy on the chopping block is a low nobility metal, and we have our king over here with he's a high nobility metal. and there is a dissimilarity between them. So our Axeman is the electrochemical process, and the higher nobility starts taking those ions from that lower nobility metal, starts creating different molecules, and starts degrading that lower nobility metal. So preventing corrosion, this is very important. So that non-galvanic corrosions, that oxidation process, we want to create a barrier between the atmosphere and that water and all those chemicals in the air by using paint, coatings, powder coating, things like that, galvanization, just coat or oil. So your steel stock, if you don't want that stuff to rust, just put a coat of oil on it. And there is this natural passivation, and this is why aluminum is a great material, because you see it creates a very dense aluminum oxide layer that acts like a coating and prevents moisture and oxygen from attacking it. That's why it's used a lot in water, building docks and things like that. And you can actually induce passivation. And this is showing an anodization process on aluminum. And you can see how they grew these columns in there using a process in an electrolyte with electricity, and they actually grow down into that material and create this very porous layer that they fill with coloring and things like that. That's why Apple uses that on their products, because it's such a durable color coating. And looking at galvanic corrosion, you need to electrically isolate the materials that are dissimilar. So you want to break that circuit, you want to open up that circuit so it can't allow that process to take place. Or we can actually take advantage of that those electropotential differences and connect a sacrificial anode, something with low nobility that we don't care about if it erodes, but that will actually protect the base material. So here's an example of a zinc anode that you would install on an outboard engine. And here is a hot galvanizing process where they're making basketball goalposts that for schools or something that are going to be out in the weather, so that zinc coating will erode over time and protect that base metal. And even polymers don't really corrode, they degrade. You could call it corrosion, that's fine. And it's caused by UVs, radiation, free radicals, oxidizers, ozonation, chlorination, and even heat affecting. So polymers, we're talking about rubbers as well as plastics as well. And it's a breakdown of the polymer chains is one way. So polymers are just a bunch of these chains, and you start breaking those down. And as well as loss of additives, the plasticizers within that polymer. You can see the plasticizers sort of hold apart those chains, the polymer chains, and separate them, and gives it more flexibility, and it makes it less brittle. So here's this is why you want to keep your dashboard clean. You can actually protect your dashboard from that UV radiation and sort of hold in those plasticizers, or else your dash is going to crack like this. As well as like old trailer tires or old cars, you see the rubber starts dry rotting, they call it, and cracking, and that's caused by UV and heat and those things that we talked about. Well, that was our corrosion video. Thank you for watching.